Welcome to Homework Lib.
In problem 96, we have a camera with a focal length of 90 millimeters, and I've converted this to meters, but I should tell you that in order to avoid any conversion issues, when you solve this problem on your own from the outset, it's probably easiest if you convert everything else into millimeters. Um, so we're also given that initially you have an object that's located at 1.3 meters, so that's our S, and you're asked to find where the sensor of the camera should be for the camera to be in focus. And in focus in this point means that your sensor is where the image is formed. In other words, the sensor is at the S prime distance. And we'll also ask to compare it to the case when the object now is at some distance that's farther away, 6.5 meters to be exact. And then what is the location of the sensor now for the camera to be in focus? So again, the idea here is to find S prime. And so let's go ahead and tackle when S is 1.3 meters. So we'll use equation 16. So that is 1 over S plus 1 over S prime is equal to 1 over F. Our goal is to find S prime, so we can rearrange this to look like this, right? And then we can put the right side under a common denominator um, by multiplying this 1 over F term, top and bottom, by S over S, and then this 1 over S term multiplying top and bottom by F over F, right? Uh, and so we have 1 over S primed is equal to S minus F over S times F. And then let's flip this around. So we have S is equal to SF over S minus F. And this is the primary equation we need. All we have to do is basically substitute. So the focal length is fixed, and what we'll do is basically change the S, and that'll give us the new S prime, right? So in one case, S is 1.3. In another case, S is 6.5. So let's examine the case when S is 1.3 meters. So then we have S prime. Let me write our equation up here. S prime is equal to SF over S minus F. So now I have 1.3 meters times 0.09 meters divided by 1.3 meters minus 0.09 meters. And if I plug this in, then I find that S primed is equal to 0.097 meters. And that is equal to 9.7 centimeters, which is equal to 97 millimeters. Okay, so I basically converted. So 1 meter is equal to 10 to the 2 or 100 centimeters, and 1 meter is at the same time equal to 10 to 3 millimeters or 1,000 millimeters, right? And you also have that 1 centimeter is equal to 10 millimeters. So these are the conversion factors if you want to use that. But like I said, it's probably easiest if you just start out with converting everything to millimeters. So we have just examined this case. Now let's examine the case where the object is farther away. So we have S prime now is equal to 6.5 meters times 0.09 meters, and we have 6.5 meters minus 0.09 meters. In this case, I have 0.091 meters, and if I multiply this by 10 to the 2, then I have 9.1 centimeters, or 91 millimeters. So here, for the case where we're closer, when the object is closer to the camera lens, we have an S prime of 97 millimeters. And then when it's farther away, we have an S prime of 91 millimeters. So what's happening here is when the object is farther away, the image is closer to the lens, and then when the object is closer to the lens, the image is farther away, right? So when you compare the two, so that's what they asked us to do. So we find that when the object is farther away, the image is closer, or the sensor is closer to the lens, because for the camera to be in focus, as we said before, the sensor needs to be where the image is formed.